Hey, what's up guys? Hope you all doing well. I'm Marvin from Precision Data Science. Today we'll be dealing with the school shooting dataset based on Washington Post research. In this dataset, we have information based on 387 school shootings since the infamous Columbine High School incident in 1999. One critical focal point is the resource officer column, which indicates the presence of school resource officer or the SROs during the incident. Machine learning may guide us evidence-based policies, aid school in refining staff training based on SRO likelihood, and foster community engagement. So can we use machine learning to predict the presence of SROs? Let's dive into the video and find out. First, we are going to import necessary libraries such as NumPy and Pandas to work on the array data and data frame. Next, we are importing Matplotlib and Seaborn for data visualizations, and then ignore the warnings to have a cleaner output. We'll read the CSV file using read_CSV method and assign it to our data frame df. df.shape method shows the number of rows and columns. Here we have 387 rows and 30 columns. We'll display the first few rows and the last few rows using the head and tail method. Here we can see that all the columns from first 5 rows starting with the Columbine High School incident. Next we have different columns belonging to temporal information, school information, incident details, shooter information, demographic information, etc. df_info method provides a summary of data frame which includes missing values and data types for each columns. Here we have 387 entries and all are non-null values, which means that we don't have any missing data. Next, df.column method shows the columns in the dataset. By observing the killed, injured and casualties column, we can see that the casualty column data is the summation of killed and injured values. So we can drop the casualties column. Before that, we can check the unique values in the casualties and the killed column. In the casualties and killed column, we can see that the most repeated cases have 1 and 0 values. Cases with 0 value basically implies that the shooting has happened, but no one died in the incident. We can drop the casualties column with the drop method and in place equal to true. Next, we can check the unique values to understand the diversity of the data. Here, some columns like school type, gender shooter 1, shooter deceased 1, resource officer column have binary values, while other columns have more diverse data. Next, we're going to check the distribution of the incidents based on SRO's presence using value counts and the sum method. Here we can see that we have 282 incidents with SRO being absent and 105 incidents with SRO being present. Clearly, we see roughly 3x more shooting incidents with SRO being absent. Next, we're going to plot the number of people killed each year along with the exponential moving average. We can apply unique method to see the unique data for years in the dataset. Here we are assigning the unique years to the variable years and number of people killed each year to the variable num_killed. And then we are creating a data frame for plotting. We are also plotting 4-year exponential moving average to see the trend for each term of presidency. In this graph, we can observe that after each election year, there is a spike in the shooting incidents, especially after 2020. And then there is an increase in the shooting incidents a year following that, except after 9/11 incident. For day of the week column, we'll check the unique values with object data type and create a dictionary to assign numerical values to the object data type. We'll use the replace method to replace the object data type into a numerical data type. With unique method, we can see that the days have been replaced with the numbers. We're going to import label encoder from the scikit-learn library and convert all object data type in the categorical columns to numerical data types. Since staffing column has float data type and staff numbers are discrete in nature, we can convert the data type into integer data type. In order for the machine learning model to work, we have to separate the features and the target column. For the features, we are considering all the columns except the target column, that is the resource officer column, and for target column, we are considering only the resource officer column. For training the machine learning model, we need to split the data into training and testing set. For that, we'll be importing train test split from the scikit-learn library, and we'll consider 20% for the test set and 80% for the training set with a random state of 595. With value counts method applied to the training data, we can see that we have an imbalance in the data. We can use more technique to generate synthetic samples to balance the training data. We'll import this mode from the IMBlearn library and instantiate it with a random state of 595. After fit resampling, we can see that the training data is balanced. Now let's shift gears to machine learning model implementation. Here we are using randomforest classifier, which uses a forest of decision tree to make predictions based on majority class voting. We will instantiate the model with 228 estimators and a random state of 595. After fitting the model to the training data, let's predict for the test data and assign it to a variable ypred. For evaluation, we're going to import certain metrics such as accuracy, F1 score, classification report, and confusion metrics from the scikit-learn library. As we can see, we have a good precision, recall, and F1 score of 89% for the class 0 and 75% for the class 1. The accuracy of the model is 85% and F1 score is 82%. So this is a good prediction considering the extreme values in the dataset. Now let's plot the heat map for the confusion matrix to see the comparison of actual and predicted labels. Here we have 6 cases misclassified as false positive and 6 as false negative, and rest all have been predicted correctly. Now it's time to predict on random data samples. We're going to display the value counts for the killed column in the X-test data. We can see that we have 4 mass shootings with 21, 13, 4, and 6 kills. We'll try to find the labels for these 4 mass shootings from the X-test and the Y-test. For mass shooting with 21 kills, we have Y-test with 0 label, which means that the SRO was absent. We will use 340 as the index and make the prediction using the trained random forest algorithm. Here we are choosing the index as 340 as it represents the row with 21 kills. We will assign 340 to a variable random index and assign the reshaped X-test values to a variable random data point. We will predict the label for the data point using trained random forest model and find the corresponding actual label for the given data point. After comparing the corresponding test label, we can see that the predicted label and actual label is 0, which represents the case with SRO being absent. We will try to make predictions for other mass shootings with index 0, 169, and 377. With 0 index number, we see that the predicted label and actual label is 1, which represents the case with SRO being present. Let's test for other 2 data points, and we see that the predictions are accurate with the test labels. As you can see, the model consistently provides accurate predictions for all mass shootings, irrespective of presence or absence of SROs. So that's all I have today. If you enjoyed this video so far, please like the video, subscribe, and hit the bell icon to see more content. Thank you.